Hello, my name is Samantha, and welcome back to another Girls in STEM lesson. Last lesson, we talked about objects, classes, and constructors. Today's lesson will be a continuation of that content. I'd like to introduce Lucy, who will be the instructor for today's lesson.
Hello and welcome to your 10th Girls in STEM lesson. First, we'll do a few warm-up problems to review objects and classes. Then we'll talk about variable types, setters and getter methods, and runner classes. Let's get started. Open up Replit and make a new REPL called Lesson 10. If you need to, pause the video here and resume when you're ready. Today we have two warm-ups. Our first warm-ups asks us to create a phone class. Our phone will have the instance variable brand, color, and number of cameras. It will also have an alternate constructor that takes in the instance variables. The methods in our phone class will include text, call, and do not disturb. Then in our main method, we'll create a phone named iPhone 20, which we'll use to test our method. The problem also gives us some sample output of what each method call should do. If you would like to review some of the concepts from last lesson, check out the link in the description below before continuing this video. Pause the video now and resume the video to go over the answer. Let's take a look at the key. First, we'll build our phone class. We'll create a new file in the left-hand side of Replit called phone.java. We initialize our instance variable at the top of the class. Color and brand will be strings, and number of cameras will be an int. Then we can make an alternate constructor. If you work with other development environments, also known as IDEs, then they may generate a default constructor for you if you do not provide one. However, Replit does not do this. If we can create a phone with no arguments, then Replit will throw an error. Our alternate constructor will take in each variable we want to use. Then we'll assign the given variables to our instant variables. Remember that the instance variables and the parameters of the alternate constructor need to have different names. Now let's create our method. Each of our methods will have the same structure. When called, they'll print out a different line of text. For our method headers, we make the modifier public so that the method can be called. Our return type is void since we don't return anything and we have no parameters. You can have your method print whatever you want or do something different. Finally, we'll make our main method back in the main class file. We'll create an instance of our phone called iPhone 20 and pass it the parameters Apple, Black, and 23, which correspond to brand, color, and number of cameras. Then we'll call each of our methods to check if they work. Let's move on to our second warm-up. This warm-up is similar to the first. The problem asks us to create a home class, which will have private instance variables, a default constructor, an alternate constructor, and some methods. Then in the main method, we'll create a home called myHome and use it to test our methods. Pause the video now and resume the video to go over the answer. Here's the key. First, we'll make our home class and create an instance variable. Home type and color of walls will be strings, number of floors will be an int, and has basement will be a boolean. Private is a modifier that we can use with variables. When we make a variable private, it cannot be accessed by outside classes. This means if we want to modify the variable, it has to be done inside the class where we made the variable. In this case, that would be our home class. Then we create a default constructor which will take no parameters. This sets the default information for our house object if the user does not provide us with any. In this case, our default constructors set home type to house, number of floors to 2, color of walls to white, and has basement to false. Then we make an alternate constructor which set the values passed to the constructor to the corresponding variables. To finish up the house class, we create the method paint walls, clean house, and press doorbell. These methods all have the same structure we called. They'll print something to the console but won't return anything. Finally, we go back to our main method, where we'll create an instance of our home class called myHome. We pass myHome parameters that correspond to the variables in our constructor. Then we call each of the methods to make sure they work. Now let's get into the actual lesson. You've been working with variables since our first lesson, so you should be pretty familiar with them. To review, a variable is an abstract symbol that refers to some particular value or mathematical expression. We talked about the modifiers in Lesson 8 and how we can make methods public or private. We can also do this with variables. Public variables are variables visible to all classes. To make a variable public, we add the public keyword in front of the variable type and name. Private variables are only visible to the class to which they belong. To make a variable private, we add the private keyword in front of the variable type and name. Each of the classes we made so far represent objects. When we make object classes, we'll use private variables. But wait, then how will we access our variables? We could use something called setter methods. Setter methods, also known as mutator methods, can change values for us, rather than directly changing the variable. Why might we do this? Setter methods can help us with debugging, adding additional features later, and allowing different access levels for people who use your code. Setter methods are methods that can take in a value and set a specific variable to the value when called. So let's look back at our dog example from Lesson 9. With a few attributes, including the breed, age, and color of the dog, if we wanted to set the breed of the dog object, we could create a method called setBreed. We take in a parameter b, then set our class variable breed to b. Recall that our parameters need to have a different name than our class variables, otherwise we'll get an error. Now, let's talk about getter methods. In our classes, we'll want to access certain variables or values. We can use something called getter methods, also known as accessor methods, to do so. Getter methods are methods that can return the value of a specific variable when called. If we think back to our dog example, you could ask for the breed of the dog object. Our method could be called getBreed. That would just have a return statement and the variable that we want to return. Our return type would be a string, since breed is a string. Every getter method will need a return type and a return statement. So, how do we test our code? Right now, we're using the default main class and the method that Replit automatically generates for us. For the past few lessons, we've also made separate class files. However, in some programs, we may have many classes and object classes in a single folder that we want to test. In this case, it would be more helpful to have separate file to test each class, rather than trying to test everything in the main class. How could we do this? We could use something called runner classes. Runner classes are separate classes used to specifically test codes. These classes will have a main method in the familiar form public string void main string arg, but not the main method. Usually runner classes are named similarly to the classes or objects they test. For example, dogrunner.java would likely test dog class. We can make as many runner classes as we want, and we can use them to test various classes. Well, what if we don't want to use a class as an object? So far, all of the classes we made represent an object like a dog or a house. If we wanted to test a block of code that wasn't meant to represent an object, we could use a static method inside of a separate class. Static methods can be called without creating an instance of a class. A static method belongs to the class rather than object of a class. Let's look at an example. Here is a set of classes. We have a class called RayDown and our runner class downRunner. RayDown has a single static method called go that takes in an int array and returns a Boolean value. Note that the RayDown does not have a main method. Go will return true if all the numbers in num array are in a decreasing order. Let's look at the runner class. Notice that we only use print statements. We do not create an instance of the RayDown class. Instead, we directly call the go method from the RayDown class and pass it as a simple array. Then we print the results. Let's do some practice problems. We have 2 for today. Bring up your code from warm-up 1. We're going to add some setters and getter methods. We'll make one setter method for all of the characteristics called setCharacteristics. Then we'll take in the brand, color, and number of cameras of our phone. Then we'll make a separate getter method for each of the characteristics. Then let's make a runner class for phone runner. If you're using an IDE other than Java, you should be able to create a runner class. Replit does not support them, unfortunately, but we can still practice. Make the runner class, but do not actually test using the main method. In both cases, we'll set the characteristics of our phone to Nokia, space gray, and 0. Then we'll use the getter method to print them. Pause the video now and resume the video to go over the answer. Here's the key. To start, let's follow the naming convention given to us and create our method header. We'll have setCharacteristics, which takes in 2 strings and an int, and assigns the inputter parameters to the class variables. setCharacteristics does not return anything, so the return type is void. Then we'll have our getter methods. Since their function is just to return a variable, they don't take any parameters. The body consists of a single return statement with the corresponding variable. Next, let's create our runner class. Just like in the warm-ups, we create an instance of the phone class and pass it some parameters. Then we'll set new characteristics, which should overwrite our original parameters. Finally, we'll call the getter method to return these values and check if our changes went through. The only difference between the main class and the phone runner class is in the names. In both cases, we have the main method that runs the main body of code. Here's our second and final practice problem. Let's make an employee class. Just like the previous exercise, we have private instant variables and setter and getter methods. We'll also have a few custom methods. Our first method is called calculateSal, which will calculate our employee's salary using the value of minimum wage and the hours the employee worked. Our second method is addWork, which checks if the employer works more than 8 hours. If they did, then we'll add $10 to their salary for each extra hour. Finally, we'll make another method called employerInfo that will print all the variables. Back in the main class, we'll calculate the employee's salary using the sample data. Pause the video now and resume the video to go over the answer. Here's the key. This solution is a bit long, but stick with us. First, we create our instance variables with the appropriate variable type and the private modifier. Then we can create our alternate constructor that takes in all of the instant variables as parameters. Here's a new idea that we can use with setters. Since we have setter methods, it would be a good idea to use them when we create an instance of our employee class. That way, if we change the way that we set our data values, we only need to change the setter method rather than also change the constructor. Next, let's create our setter and getter methods. We'll follow the naming conventions of set and the variable name of our setter, and get and the variable name of our getters. Each setter will have a similar format, where we'll take in the variable type and set it to a specific variable. Then our getter should return the variable corresponding to the name. Now, let's create our custom methods. To calculate the employee's salary, we need the minimum wage and the number of hours the employee worked. These variables become our parameters. Then, to calculate the employee's salary, we multiply the minimum wage by the number of hours the employee worked. Then we'll add the overtime pay using the addWork method. This value is passed to the setSalary method. Next, we create our addWork method that will check if the employee worked more than 8 hours. If so, then we multiply 10 by the extra hours worked. We can use the formula salary equals base plus 10 times the quantity of x minus 8. You may have noticed that we could combine the calcsol, addWork, and setSalary method to make our calculations even simpler. Try it now if you want to. Our final step is to make a method that will print all of our employees' info. The print statements will use getters to get the values and will have text descriptions in front of each variable. That way, when the statement is printed, we'll know what each number represents. To wrap it up, we'll create an instance of the employee class using the given sample data, and we'll call each of our methods.
Hi, I'm Alexis. Thank you so much for watching and congrats on completing your 10th Girls in STEM lesson. If you have any questions, comments, or concerns, please feel free to reach out to us at our email ccagirlswhocode@gmail.com or comment down below.
We really want to thank the following on the production team for all their hard work that went into this lesson. All of the slides and videos in the series are available on our website as well as the description below. Although this is our last lesson planned for a few weeks, I hope you'll join us again for some cool Java projects.